Hi everyone, here is Teacher Regan. I want to once again welcome you to Easy Elimu, where learning is simplified. So in our lesson today, we are going to discuss fractions. And under fractions, we have so many other substrands that can be discussed. For example, we are going to discuss comparison of fractions, addition of fractions, multiplication of fractions, and division of fractions. So maybe just to introduce our topic today, so we can define in simple terms what fractions are, or a fractional number. Definition. In other words, fraction means part of a whole. It means a fractional number is not a whole number, it's a part of a whole number. And what of a fractional number? A fractional number, or rather a fraction, or we can call a fraction is a number, or we can say a fraction is a number written in the form A over B, where A and B are integers and B is a positive number, or rather, and B is not equal to 0, or B is greater than 0, to mean B is a positive number. In most cases, the denominator is always a positive number. The number A is the numerator and B is known as the denominator. Normally, a fractional number is written in simple terms, in simplified form. Yeah, in simplified form. I.e., the numerator A must always the numerator must always be smaller than the denominator. A must be smaller than B. However, if A is greater than B, then the fraction takes the form of a mixed number A over B. So the first thing we are going to discuss under fractions is comparing fractions. Comparing fractions. So what I'm saying here, in most cases, whenever you are writing a fractional number, maybe before we discuss comparing of fractions, let us look at an example of fraction. Examples of fractions. Examples of fractions. We can have a half. We can have Roman 2, 4/5. Roman 3 can have 7/13. So these are examples of fraction, and that's why I'm saying normally a fraction number is written in simplified form. That is, the numerator must always be smaller than the denominator. In other words, look at here. In this case, 1 is our A and this is our B. This is our A and this is our B. 7 is our A and 13 is our B. However, in situations whereby A is greater than B, then that particular fraction must be simplified, and when that happens, it will take the form A/B, where A uppercase represents the whole number part of that fraction. For example, e.g., if you have a fraction like 5/2, this one, when you simplify, 2 goes into 5 2 times, remainder 1/2. So this takes the form of A uppercase A/B, whereby A uppercase is 2, A lowercase, which is the numerator, is 1, our denominator B is 2. So that is all about the introduction of fraction. So let us discuss comparing fractions. So when we are comparing fractions, we tend to know how do you know which fraction is greater than the other, or which fraction is smaller than the other. So right, when comparing fractions, we get to arrange fractions in either ascending order, in bracket from the smallest, or descending order that is from the largest. So whenever you are comparing fractions, you must know which one is the smallest fraction here, or which one is the largest fraction in the following sets of fractions. Then after that, you will arrange them either in ascending order, whereby you start with the smallest fraction and you end with the largest fraction. Or you can alternatively arrange them in descending order, whereby you start from the largest fraction possible, going all the way to the smallest fraction. So let us discuss methods of comparing fraction. Methods of comparing fractions. So here we have LCM method and percentage method. Percentage method. So you can either get or solve the LCM of the given fractions, then from there you express each of the fraction as the denominator, which is the LCM, or you can alternatively convert all the fractions given into percentage by multiplying each of them by 100%. Then from there you compare the resulting percentages and you'll be able to know which fraction is greater than the other. So let us look at an example. Using both the methods very fast. Example. Example. Example, you can have arrange the following fraction in increasing order. Example, arrange the following fractions in increasing order. So the fractions are, we have 1 over 2, 9 over 10, 3 over 5, and a quarter. 1 over 2, 3 over 10, 1 over 2, 9 over 10, 3 over 5, and a quarter. So this is 9 over 10, 3 over 5, and 1 over 4. So solution, here increasing order is the same as ascending order. Ascending order. So when you see the word increasing order, that is the same as ascending order. So here let us use method 1, the LCM method. Method 1, LCM of the denominators. LCM of the denominators of the fractions given. So our first denominator is 2, second is 10, the third is 5, and the fourth denominator is 4. So we solve the LCM, that is our method 1. So 2 here, 1 into 10, 5, cannot go into 5 completely, we retain it, 2 into 4, 2. So we have 2, we retain that, we retain this and this, then 1. Then finally, we have 5, 1, 1, 1, 1. Therefore, the LCM of the denominator is 2 times 2 times 5, that is 20. So we are going to express all the fractions as a denominator of the LCM. So 2 into 20, 10. 10 times 1. So that is, this is over 20. So that is 10 times 1, the first instance. We have a comma. Then 10 into 10, 1 times 9, that is 9 times 1. So we have 5 into 10, 20, 4 times 3. The second one is 4 times 3. And finally 4 into 20, 5 times 1. So that is 5 times 1. So with respect to LCM, the first fraction will be equal to a half. With respect to LCM will be equal to 10 times 1, that is 10. The second fraction, which is 9 over 10, will be equal to 9. The third fraction, which is 3 over 5, will be equal to 12. Then the fourth fraction, which is 1 over 4, will be equal to 5. Then you compare these corresponding numbers. Then from there, you'll be able to know which fraction is the smallest. Ascending order, you start with the least to the largest. Hence, this is our order, 1 over 4, because 5 is the least, followed by 9 over 10, followed by a half, then followed by 3 over 5. So that is the ascending order. So we are starting with the least one. 9 over 10, not really. Here, 10 into 20 is 2 times. So this is times 2. So this gives us 18. So we have, that is 2 into 20, 10 times 1, 10 into 22 times 9, then this is 4 times, that's 12, then this is 5 times 1 is 5. So we have 10, so the least fraction here becomes 1 over 4, followed by 1 over 2, followed by 3 over 5, and finally we have 9 over 10. So we have 1 over that, 1 over 4, a half, 3 over 5, and 9 over 10. Let us solve the same question using method 2, which is percentage method. So we'll take the first fraction, which is a half times 100%, 2 here 1, here 50. So 50 by 1, that is 50%. So that represents 50%. The second is 9 over 10 times 100%. This is here, that is 10 times 9, that is 90%. The third fraction is 3 over 5 times 100%. 5 here 1, 5 into 100, 20 times 3 times that, that is 60%. Then the fourth is 1 over 4 times 100%. 4 here 1, 4 into 100%, 25%, times 1, you'll get 25%. So from there we can compare the percentages. The least percentage is represented by a quarter. That means a quarter is the least. Then followed by 50, represented by a half. Then followed by 60, represented by 3 over 5. Then lastly we have 9 over 10, which represents 90%. So you can see in both cases our answer remains the same. So you can use the concept of percentage or LCM to compare fractions. Questions? 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 Kindly take down these questions. Arrange, number 1, arrange the following fractions in decreasing order. Decreasing order in this case is now the descending order. The descending order. So that is number 1. So we have the fractions given as a quarter, 3 over 7, and a sixth. We can have a quarter, 3 over 7, 3 over 7, and 1 over 6. Number 2, compare the following fractions and arrange them in an ascending order. So we have a third, a sixth, a eighth, a half, a quarter, 5 over 6, those ones. So kindly do those questions, and of course many more other questions that you'll come across regarding comparing fractions. Otherwise, thank you for your time. See you next time.